go. We're on.
Andre, we're just going to let the participants come in there. Hey guys, good to see you all signing in. Record numbers today. Going to hand you over quickly to Katie. You may remember our events coordinator. She will talk you through some of the upcoming ideas.
Hi everyone, nice to see you all. Well, virtually. So yeah, as you can see, also I'm blocking the barcode. I've got the code for Slido here. We'll kick off with the card game, and then if you have it open, we're going to have a quiz halfway through and use it for the Q&A as well. So really important that you log in. I'm going to put the link in the chat as well, just in case you have any problems with the barcode. So I'll just do that now. The Slido link. So let me just pop that in for you. So let's chat.
More
Chat. Two. Okay. So there you go. The chat. The link is in chat for Slido. Hope. Let me know if you can see that.
Yeah, it's there.
Yeah, perfect. Okay, so either the barcode or the link. So yeah, kick off at 12 o'clock. We're looking forward to it. Card game first. We've got the nice Gopher cards up for grabs and a couple of other prizes. Very excited. Good numbers coming in. Record numbers coming in, sorry. Record numbers. Cool. Where is this chat? Why can't I see it? That's it. Cool. Okay, you can see that. Lovely. Yeah, so you should be able to see on the Slido now. We've got topics. Let us know of any topics that you'd like to have talks on. Best practices was a popular one from last time, which is why obviously we're doing this now. And anything else, let us know, and we'll do what we can to get them involved in the e-meetups. Cool. So whilst we have the polls open, you can always on Slido, it should be sort of self-explanatory, but click to the Q&A to put up any questions that you have for Andre throughout. So you can see all that there. I think we're good to got good numbers in. So let's kick things off. I'll hand you over to the Joes.
Hi, Gophers. Just sliding in and out of visibility here. For those that didn't attend last time or don't know us already from the Go community, we're the two Joes here. We're the directors at Go Naviro. We specialise exclusively in Golang resource solutions and do a lot in the event space, previously live and now in the online arena, putting together this series, which we're really excited about. This is event 2. Today we got Andre Eriksson, a very experienced Go practitioner, ex-Spotify engineer, doing some really cool stuff with a brand new framework. Going to be talking about a lot of best practices as well. So hopefully, yeah, plenty of value for you guys. Joe will talk you through the format for today.
Yeah, great. Like as Joe said, you may remember from last event that we had a Gopher card game. We are going to be kicking off with that for the next 5 minutes, just while more people enter the room. So do remember to keep registering on Slido for your chance throughout to win our limited edition Gopher cards. We will be giving these away to the winner of the Gopher card game, and obviously for Slido to keep registering for questions submitted to Andre throughout. After that, we'll just kick off with the talk from Mr. Eriksson. He'll be going through it for the next hour or so, questions throughout. So keep tuned for that. And yeah, we'll be wrapping it up within about an hour or so. So we'll get it underway here, guys.
Yeah, just as Katie mentioned earlier, just remember to post your questions in. If there's something you really want to answer, Andre's going to do his best after the talk to get to those questions. There'll be a prize for the most liked question. So if there's something you really want answered, make sure you give it a like. and bump it up so that they can be addressed at the end. And yeah, we'll without further ado, we'll crack into the Gopher card game, which should be loading up very shortly.
Should be on your screen. We've got 5 logged in so far. We'll let a few more get in. So
turn the camera off as well.
For those that didn't play last time, it's a very simple concept: higher, lower, or the same. Me and Katie, the events manager here, actually ran this out yesterday on the dining room table, so they are pretty random. So yeah, don't hold it against us, and let's see who can come out on top and take a pack of these fantastic Gopher playing cards. They're pretty cool. So
you've got 13, 14 registered so far. The numbers are going up quick. We'll give you another minute or two just to get in there. Pop your name in so we know who's the winner. I can see some names from last event. 15 so far. Couple more minutes. Look at this. Big numbers.
All right.
Cool. We're up to 22. You may have seen these throughout, by the way. I have been relentlessly plugging them. You can see them in and out of shot there. Not sure what you can see, actually, because shared screen. But the limited edition, we will be giving them away along with a few other prizes throughout. So, really looking forward to this. Big numbers now, 29, 30.
All right, should we get into it?
We get into it, yeah. Right, let's kick it off.
So higher, lower, or the same? We've got 6.
6. Ooh.
Joe's going to be playing this.
I'll play along with this one as well, so you can see.
And higher. All right. So nothing.
It is.
Right, let's go on to the next one. Oh, sorry, 56% went higher. We haven't had the answer yet. Let's go on to the answer.
Yaroslav getting that one right. We got a few right answers, actually. So fair play.
How did I miss the answer then?
Right, 6 again.
Okay.
This isn't a loop.
All right.
We're not glitching.
That makes sense. It was a 6, yeah. So whoever went the same, higher or lower, all the same. 58% went higher.
Right.
Yaroslav is leading the way. Remember, it's fastest finger as well as getting it correct. So Yaroslav is still ahead. Oh, a 9 ball. Right. Okay, so
curveball with ease.
Higher, lower, or the same.
Never easy. Never easy, a 9.
Completely random, of course. All righty. Let's go.
Brilliant.
Lower.
We got 57 up. We missed there, but we'll have to find out after. I think Yaroslav was still.
The results will be after this one, guys. So good luck. It's the last one. Higher or lower on a 5? Or the same, of course.
Love it. Got to go. 73%.
Higher. And the answer is.
Abhishek has taken the lead here, though.
Abhishek, I think, has just taken down the comp.
Oh, no, we got one last card. 4.
It was a lower. Whoever went lower on that last one. Sneaky. All righty.
74 higher on a 5. You've got to be right, haven't you? It was correct. Well done.
Abhishek, congratulations.
Congratulations. I think this is just to wrap it up.
This is the last one to wrap it up, and we'll go on to the official leaderboard. But let's see if there's any impact there.
Yes, absolutely.
Go on, a lot of positivity there, like that.
Oh, and there was a snatch right at the last minute. Someone's got in there. Lovro with a win.
32 seconds, snatched it from the jaws of defeat. And not too. We got 2 packs to give away by the looks of it. Looks like Liam G is going to be hard done by there as well. So well done, guys. You'll have 2 packs on the way to you. We'll get in touch with you after the event and ship them over to you. So I hope you enjoy playing a few games with them. And next, what we're all here for, the main event, Mr. Ericsson, who will make host of this now, and we'll be cooking through some really interesting topics here in Go. So enjoy, guys.
Yeah, we'll hand you over just now.
Let's get that onto full screener. Make host, Mr.
Lovely.
Ericsson. Alrighty. Cool.
Stop the screen share.
All right.
All right. Get her off of there.
And I'm going to share my screen and we'll get going. There we go. All right. Really great to be here and really, really fantastic to see that so many people took the time out of their day to come and listen. And really awesome to see the winners of the card game as well. So I'm Andre. I'm the founder of a company called Encore. I'm a long-time coder, software engineer. I was at Spotify for the past 8 years. And when I'm not doing that or other, hobbies and so on, I'm taking care of a little puppy called Salvador. He's really playful and likes to bite people. So that's him. And what we're really here to talk about today, right, is Go best practices, focusing on interfaces, packages, and APIs. And so what does that mean, right? Like what is it that we think about when we are designing packages, interfaces, and APIs? The way I think about it is it's really about we want to do things the right way because we want to minimize complexity. We want our product to be as simple as possible. And it turns out that the main challenge in all of programming and software development is really dealing with complexity. And so to properly give us the tools for thinking about, how do we write the best Go code possible, I actually want to start by focusing less on Go and more about understanding and thinking about complexity. So we'd like to think that our systems are simple. What we're striving for is simplicity. In reality, this is always where we end up. We end up with, over time, especially if we keep shipping features as quickly as possible, this is where we end up. And inevitably, it hurts, right? That's the tagline. And instead of really being able to spend that time on implementing new features or building products that our users love, we get bogged down in complexity, infrastructure, configuration, boilerplate, and so on. So since we want to minimize complexity, we need to start by talking about what is complexity. And what you see here is a bunch of cables. It looks, I don't understand what's going on, but you can tell that there's some sort of organization here. Like there's been thought put into this interface. Like it's organized, it's clean. People have designed this in a way that maybe I don't understand, but they are the experts and they understand. So this isn't what I would call a complex system. And then if you get here, is this a complex system? Well, it's certainly a bit more chaotic. There is some sort of organization, but definitely feels more complicated and more complex. And what about this? Or this? Or this? The reality is it's really hard to define complexity. And it often feels like I know it when I see it. I can't tell you what it is, but I can tell you when something is complex. And if you look in a dictionary, it says, the state or quality of being intricate or complicated. And this isn't very helpful because we're kind of just moving the goalposts into the word complicated. So there's this really fantastic book by John Ousterhout called The Philosophy of Software Design that says that complexity is really anything related to the structure software system or program that makes it hard to understand and modify. And this is much more practical for our use cases, and it gives us something to reason about. Now, I can highly recommend this book for anybody that's building software. It has lots of practical ideas and ways to reason about complexity. And we'll be touching on more concepts from this book during this presentation. And one thing that I think is really helpful is, making this slightly more concrete or well-defined by actually coming up with a complexity equation. And what this is saying is roughly that the total complexity of a system is the sum of the complexity of all components of the system, or all parts, P, multiplied by the fraction of time that we're actually spending developing in that part. And what's really interesting about this is that if you have a part of your system that is really incredibly complex, but you're not spending any time developing that part, it turns out that it doesn't actually add any complexity to your system. It's just there, it solves a problem for you, and you can kind of just ignore the complexity inside. And this is really the key insight, is by hiding complexity behind an interface, we can isolate that complexity from the rest of our system. And this is actually also supported by how our brain works, and this concept called chunking. And researchers have figured out that as humans, our working memory can really only hold a couple items, in our minds at the same time. And it used to say, people used to think that this was around 7, but recent studies have shown it's actually closer to 3 or 4. To just illustrate what I mean by this is, if I ask you to memorize this string, you're going to have a hard time, like MD, PhD, you're going to have to remember like all of these, 15 letters. But when you actually break it down into something that you can reason about, and it's a concept that you understand, suddenly you're not thinking about all 15 pieces, but really just the 5 words or acronyms. So MD, PhD, RSVP, CEO, IHOP, the International House of Pancakes, if you're not aware. And this really is analogous to how we should be thinking about software, right? If we have a component of our system, we really need to leverage chunking to break it down into something that is more really modular, right? So modular design is really how we make sense of large-scale systems. And it impacts, as we'll see, how we should be writing Go code. And to really illustrate what modular systems are, things often feel simple in isolation. But when you combine lots of them together, it doesn't feel so simple at all. So modular design is really all about, it's not just like finding ways of dividing our system into, let's call it services. We can really keep dividing it again and again and again. So modular design is all about breaking things down into smaller pieces. And we can keep doing that in kind of like a fractal way. And each piece can be further divided and have more internal structure. And to make that a bit more about Go, and using backend development as an example, when you think about modularizing a backend, usually the top level concept is the whole backend application itself. And then if you go a step down, you have systems. And by this, we mean like large scale systems that accomplish a really big part of what your backend application is doing. And when you zoom in a step further, we have services. And services, at least in modern backend development, we usually mean like a concrete piece of software where other services are isolated via network boundary. So between services, it's a network via TCP or UDP. And within a service, it's a single process. And there we're dealing with components. So we can further subdivide services into having multiple components. And then each component can consist of one or more Go packages. And this, I think, is a really helpful subdivision. And you can even take it a step further where we can, within each package, we can reason about types and functions and so on that are essentially even more smaller divisions than the package itself. And so, to be clear, we can't just, break things down willy-nilly or any way at all. It matters a great deal how we actually break things down. So it's not sufficient to break it down. We really need to think about how we break it down. So how do we reason about that? What is a good breakdown and what is a bad breakdown? And the key really lies in interfaces. So what do we mean by interfaces? Go has an interface keyword. Is that what we mean? It's not really what we mean. We mean, if you look in a dictionary, an interface is a point where two systems, subjects, organizations, and so on meet and interact. So it really has something to do with interactions between things. In our case, services, packages, types, and so on. So different types of interactions or communication. These are all types of interfaces. Like a phone is an interface for speaking with another human being, or a robot, as it may be increasingly these days. Maybe a more helpful description in our world of software is a device or program that enables a user to communicate with a computer, or taking it an even step further, programs communicating with other programs or parts of our program. So interfaces are really about how we enable communication and what are the ways that one part can communicate with another. And so to properly divide our application into modules, we need to think about what are the interfaces between modules. And that's really how we can successfully manage complexity, is in thinking about these interfaces. And, unfortunately, these days, a lot of programming is done with a very short-term mindset. And oftentimes, we as developers have good intentions. We want to do things not in a hacky way. We want to have a long-term mindset, but there's a constant pressure to deliver quickly. And it kind of forces us to focus on short-term value over long-term technical health. But other times, it's actually self-inflicted. And it actually comes down to, we don't really feel like we should be thinking ahead. Because if you try to encourage, like, we need to plan ahead, we need to think ahead, there's this worrying trend in our industry that anything forward-looking or thinking is a symptom of the dreaded waterfall model. And if you're not familiar with that it's a project management methodology that essentially is a much more linear project planning method than what we're nowadays used to with Agile, where it's much more iterative and it's much more rigid. And for that reason, it ended up being a poor fit for most software development. And nowadays, most of us are working with Agile, but we've kind of taken it to an extreme where planning ahead in any way, shape, or form is seen as a bad thing. And as with most things, both extremes are bad. And the right balance is somewhere in the middle. And I tend to believe that for most software development, we're actually too far on the short term and not enough long-term thinking. And we can do Agile while still thinking ahead a couple of steps. And it turns out that, so for the first best practice of tonight or today, is that to really design great interfaces requires thinking ahead. So let's talk a bit about interface design and what that means. Again, from Austerhout, the book, there's this really helpful concept of, the shape of an interface. And you can think of the size and complexity of the interface is this red box on top. And the blue box is the amount of functionality that the interface is hiding from you. And what we're really aiming for when we're designing an interface between two modules is to minimize the complexity and the size of the interface while maximizing the amount of functionality. So the left-hand side is what we call a deep module, and on the right-hand side is a shallow module. And this means that deep modules tend to abstract and hide complexity and isolate complexity much better than shallow modules. So if we have freedom to choose, we should aim to design deep modules over shallow modules. So to make it a bit more concrete and Go specific, here are two standard library packages. So we have compress gzip2 and syscall. Now, if you take a look at these, the gzip2 package, it has literally one publicly exported function, a single type, and one page of documentation. But the implementation itself of gzip is by no means straightforward. It actually consists of over 1,000 lines of code. So there's a lot of complexity hidden in an incredibly simple interface. So this is a very, very deep module. On the other hand, we have the syscall package with its over 200 functions, over 70 types, and 85 pages of documentation. And this is, I actually couldn't get a screenshot of this because it couldn't fit on my screen, even if I zoomed out as much as I possibly could. So if this is a deep module, the syscall package is an incredibly shallow module. And this is not to suggest that the syscall package is bad, because the purpose it's serving is not to, hide a bunch of complexity from you. In fact, it's kind of the opposite, where the syscall package is designed to expose the underlying kernel interface. So we can't say that shallow modules are universally bad, but when we're designing to manage complexity, that's not what we should be optimizing for. And a third example is the net HTTP package, which has 95 functions, 24 types, and 56 pages of documentation. And I want you to think about this as I continue the rest of the conversation, whether this is an example of a deep module or a shallow module. It certainly has a lot of interface, like a really big interface, right? So that brings us to best practice number 2. And that's that great modules are deep. So if we want to create deep modules by hiding complexity or isolating complexity, how do we actually do that? One thing that has been incredibly successful is the concept of information hiding. And modules that provide a lot of functionality with a small interface, they tend to do that through information hiding. And so what do we mean by information hiding? It really comes down to, like, we're not saying like, oh, make functions unexported or private. It really comes down to, how isolating the caller from some sort of knowledge. So for deep modules, we want to isolate the caller, meaning the user of the module, from something. And it tends to be actually isolating them from design decisions of some sort. So for example, TCP is a good example where you have the net package which implements TCP, or the Linux kernel and so on. The TCP protocol is incredibly complicated, and there are lots of sub protocols that you have to think about to do this really well. But as a user, you don't have to think about that. So TCP is isolating the user from like congestion control and so on. The Go language uses garbage collection, but it doesn't actually talk very much or require you to think about the specific garbage collection algorithm. In fact, it has changed many times over the history of Go. Or a file system where we have files and folders and so on, but the underlying representation of bytes and bits on a physical disk is not at all anywhere similar to this abstraction. So it's all about isolating the caller from design decisions of some sort. That's information hiding. So interfaces then create problems. Wait a minute, that's backwards. They solve problems. So really great interfaces, they're not designed to, they're here to provide value and really a service to the user and consumer of them. So I think a really good way of thinking about this is that when you're designing an interface, you should be doing it with the consumer of that interface in mind. And I've seen so many times where, you're building a microservice or something, and you're making decisions to make it easier for you to implement, rather than making it easier for your users to use your API. So just like how, code is read much more than it is written, interfaces are consumed much more than they are implemented. So we really should be optimizing for the consumer, because that's really why we're creating an interface in the first place, right? And another way of saying this is that we should be favoring simple interfaces over simple implementations. And a really good way of accomplishing this is actually to design interfaces together with your consumers, because that means that they will give you their feedback and perspective on whether something's easy to use. When you, as the producer, is designing an interface, you're wearing two hats at the same time. And that tends to create a lot of confusion, and you can't really keep these conflicting perspectives separate in your head. And the final point is, if at all possible, test your designs with real world use cases. And this comes back to what I said earlier about short-term versus long-term programming. It takes time to design the right interface, and you really want to test it against real-world use cases. Ideally, more than one use case. If you can find 3 different use cases that all work really well with your design, then you have most likely found a really good interface. So to summarize, the third best practice is that great modules isolate complexity. And the way they do that is through information hiding, through solving actually hard problems with a small interface, so they're deep, and by actually providing a great service to the users and consumers of that module. So with that, I want to take a break and let's do a quick quiz on what we just talked about. So I'm going to share my different window here. And we'll go to okay, so I'll wait for you to join a third quiz and then we'll get going. This is going to be okay, so is net HTTP a deep module? And here are your 4 options. And I gave you some time to think about this, so hopefully you have had some time to think about it. Wow, that's wonderful. So this is exactly right. What's really great about net HTTP is it has a really big interface. But what it does is it does so much under the hood, right? The interface is big, but the complexity it hides is much greater. And so this is definitely a great example of a deep module. It's not about making the interface small. It's really about, finding the right balance between the size of the interface with the functionality that you're providing. Great job. So next question. What are some good methodologies that make it easy to design deep modules? Agile, waterfall, test-driven development, or none of the above? Okay, this is interesting. So the right answer, maybe this was a trick question, is actually, in my opinion, none of the above. We've talked about agile and waterfall already, and they're both extremes that tend to provide bad results. But test-driven development is very much a methodology that encourages you to make small incremental improvements and implementation. And deep modules, it's all about strategic thinking and thinking ahead. So test-driven development is fantastic for writing testable code, and a lot of people find that it helps them write higher quality and more reliable code. But I wouldn't say that it like starting by writing tests helps you design deep modules and, strategically thinking about the right interface. So maybe a trick question, and maybe you're gonna write angry messages to me on Twitter. Let me know. And third question, when should you split a Go package? So this is something we haven't really talked about, but package structure is really important to Go development. So curious to hear what you think. All right. So this was also interesting. Most people got the right answer, which is that there is no real right answer. A lot of people think about concerns and a package should only do one thing. But the problem is you can always argue one way or another. What is a concern? What is not a concern? Is HTTP a single concern? Is HTTP2 a different concern? Is an HTTP client one concern and the server another? It's all, you can just argue back and forth for infinity. So to me, the right answer is really to think about the complexity. And we're talking about the complexity of the whole system and not just individual pieces. So congrats, Neil. Great job. I'm going to jump back to the presentation and we'll continue from there. So to talk briefly about package structure, because we didn't really get a chance, I wanted to do the quiz beforehand, is when should we be splitting a package? So it really comes down to minimizing the total complexity. And like we talked about before the quiz, there are really three aspects to consider. Does splitting it result in better information hiding? Does it result in fewer dependencies? And does it create deeper interfaces? And the solution that you should be thinking about really comes down to like minimizing the total complexity by taking these things into account. And the final thing I want to touch on is domain-oriented design. And this also relates to package structure. So say that we have, a system that looks like this. There are two ways of breaking down this into packages. We have on the left, maybe a spoiler, is a good design, and on the right is a bad design. So based on minimizing the total complexity, we really want to minimize the dependencies. And on the right-hand side, we have this concept where we're putting all the things in the same package. So all the models go in one package, all the APIs go in one package, all the databases go in one package, and so on. And on the left-hand side, we have a domain-oriented package structure where the billing gateway has one package, the subscription management system has another, the product catalog has a third. And this is much more, it tends to create much better interfaces between the parts, because otherwise everything will import everything. And the only commonality is that it's similar things rather than being similar concepts. So with that, one thing to keep in mind is, and this is like a bonus best practice, everything I've just talked about, there are no truths to this. It's all trade-offs. And that's what I find tricky with a lot of these blog posts on package structure, is that they try to present it as like, this is the one true way of doing a package structure. But it really comes down to trade-offs, where there are benefits of doing things one way, there are benefits of doing things another way, and your job is to evaluate your specific situation and find the right balance for you. And that's really what this concept of minimizing the total complexity is all about. And with that, I actually want to move on and talk a bit about what we're doing with Encore, which to me is really about a lot of the stuff we talked about. It's about how do we actually manage complexity when we're building with the cloud. And we're calling it a cloud native backend development platform, or a backend framework with superpowers. So what do we mean by that? We mean that there's no boilerplate that you have to deal with. We manage the infrastructure for you so that you don't have to. It deploys to your own cloud rather than us handling the hosting. It even does things like simplifying debugging and monitoring and so on, so that you can just focus on building your actual product. And we designed all of this based on the lessons we learned at Spotify. So the product really scales from whether it's a handful of users to hundreds of millions. So who is it for? It's really for whether you're a startup that's building like a web app or a mobile app, or you just really want to focus on building your product. It's for both really experienced as well as inexperienced backend developers, and really for people who want to have a more enjoyable backend development experience. And with that, I'm just going to do a quick demo to show you, and then we're going to wrap up. So what we're looking at here, actually, let me share my whole screen. That's going to be easier. So what we're looking at here is a very simple Encore application. It's actually empty. And what we can do is we can type Encore run. And I'm going to do this, exit this. Let me open this here. There we go. So when you're building with Encore, you should really be thinking in terms of data structures and interfaces. So let's say that we want to create an API that greets you, right? So what's the most go way of doing that? It would be a function like hello, let's call it hello there, and it will take a string, and we're going to return a data structure. So let's call it response. And we're going to say this, we're returning a message. Sorry, we're returning a response and an error. And because this is an API, we're going to say the message is hello world. And we're going to construct this. And the error is nil. So this is like conceptually an API, right? Now with Encore, all you have to do is take a function like this and give it an annotation. And we're going to put this on the hello name route. And once we save, we can see that Encore reloads it automatically. And on the right-hand side, we it automatically figures out that there's an endpoint here. We can head over to the documentation, and we can see here that when I save, it automatically fills in the documentation. If I rename it, it renames the API immediately, and so on. And if we go back to here, we can even call it directly from here. So we're going to say, hello, go Naviro. And we call it, we can see that we're getting hello world back. And this is because we're not actually using the name. So if we change this, hello, we use the FUMP package, and then we call this again, we can see that now it works. And if we open this up, we even get this really powerful tracing UI that is really great for debugging. Now, this is such a simple application that we don't really see the true power of this. But when you're building something more sophisticated, this is very, very powerful. And what's great about Encore is that when you're done, to actually deploy this, need to actually commit this. To actually deploy this to the cloud, all you have to do is type git push Encore. And then it will actually, compile it. It will run all the tests. Once the tests are done, it will actually set it up in the cloud and give us fully production-ready application running in the cloud. And that's really how simple it is to build APIs with Encore. Instead of thinking about HTTP and JSON and so on, we can just focus on the actual interfaces and the relationship between different services, and really focusing on building our product in a very, very Go specific way that is still very, very cloud native. It scales automatically up and down. It handles databases, authentication, and more. And it's really, really easy to get started with. Once this is done, it will be up and running in the cloud. And then that's all we need to do. Now the tests are done. It checks if there's any infrastructure that needs to be provisioned. And then we can just call this. So there you have it. It's up and running in the cloud. And that's really how easy it is. So with that, thank you so much for listening. Thank you for taking the time out of your lunch hour to listen to me talk about APIs and interfaces and packages and Encore. Happy to take any and all questions. And I believe now I'm going to stop sharing and we're going to go more into a Q&A style conversation.
Perfect, Andre, thanks for that. If you can, switch the host over, and then I can read out the results. For anyone that hasn't voted yet, we're in the last minute for the voting for the questions. Perfect. Thank you. Perfect. So we're in the final minute now for the questions, and we look like we do have a leader. And I believe the question you may have touched on it at the end of your talk there, Andre. But I will just like to read out and congratulate Rajiv for his question, 21 votes, which is looking like it's going to definitely be the most upvoted question. So well done, Rajiv. There will be an Amazon gift voucher coming over to you. And we have lots of great prizes on offer. And I just want to hand it back to Andre just to briefly kind of assess that question. You have it there?
Yeah.
Perfect.
So do you want me to read it or will you read it?
Yeah. If you want to read it out, and then if you do have, for the remaining time, I think we have 10, 15 minutes, if that's cool, just to go through the other questions. Any questions that you can't get to, we'll cover that in the post-event recap.
Yep, wonderful. So why is Encore not using protobuf? We can replace JSON with protobuf, or maybe we can adapt gRPC for code generation. This is a great question. I think, so like I touched on with Encore, the philosophy behind Encore is really that the optimal way is really to think about APIs and interfaces just in terms of their shape. What's the ideal structure that we want to have? And that, the natural way of doing that in Go is with types and functions. So conceptually, on API endpoint, if it is like a request response endpoint, is one where you have like an input type and you have an output type, or a request and a response type. And this is what Encore encourages you to use. So why it doesn't do protobuf, it really comes down to just like starting with the most common thing. We absolutely want to support protobuf in gRPC, so that, because we want people to stop thinking so much about transport protocols and really to think about interfaces in the way we talked about during the presentation and the best practices. So this is absolutely coming. But in the meantime, we do offer like you can generate a type safe API client that makes it really easy to use, for example, in a front end and so on. So with that, we will add gRPC support later and protobuf support. It's just a matter of like prioritization. There are a couple higher priority things that people are asking for that we're gonna do first, and then we'll get to gRPC and protobuf support. But absolutely agree, it's something that a lot of people have asked for, so definitely something we want to do. So next question is from Tibor. Should you avoid long-lived client connections in your API, if at all possible? And the answer to this is almost always yes. Like everything, it's a trade-off. So there could be circumstances where you really need to do this, but in a modern like microservices, or if you're using Kubernetes and so on, it's very, very hard to guarantee that the server that's running the API is going to keep running forever. Because with Kubernetes, your pods get rescheduled onto other machines and so on, and then the connection will break. So it's fine to do, persistent connections if you really need to, but it tends to work best if you have, if you gracefully handle when the connection shuts down. So the client automatically reconnects and you have some sort of way of just resuming where you left off. But it's definitely a bit more complicated. But that's what tends to be better, instead of like doing a lot of work to make sure that the connection never dies in the first place, because that is really complicated when you're dealing with stateless backend services. Next question from Yunus. What are the strategies for moving from badly organized complex system to well-organized complex systems? So that's a great question. I think ultimately, first of all, it comes down to, you actually need to figure out where you want to get to. So this comes back to what we talked about earlier with thinking strategically about what does a well-organized system mean for us. Nobody can tell you what this is in terms of, this is the best practice. It needs to look like this. If it looks like this, then it's good. If it looks any other way, it's bad. What is good for you depends entirely on your product, your business, your requirements, where you're going, and so on. So the first step is actually answering that question. What does good look like? Once you have an idea, it tends to, when you're constantly shipping new features and so on, what tends to work best is actually you really need to find a way to do it incrementally. You need to find a way of every quarter, find a way to do some small change that will move you closer to your vision. And there are lots of ways of doing that. I think one way that I've seen that has been successful is by actually, not prioritizing the work as a different type of work, like, oh, we're going to spend 10% of our time making improvements to the organization or the structure, but rather to, in every like feature you build or every deliverable that you ship, find a way to, when you're working in a part of the system that needs to be reorganized, make a small change to move it closer to where you want to be. That tends to work really well. And if you can, business people really don't like is when you stop shipping value for a long period of time. That's irrational, even from a software engineering perspective, because that's at the end of the day why we're here. But they're often very sympathetic to the idea that we've actually often, for historical reasons, we're ended up in the situation where we have a lot of technical debt or complexity, and often there is a lot of buy-in that making improvements is good for the business. We just need to do that in a way that doesn't stop us from shipping. It's much better if we ship 10% slower because we're doing this work than if we stop all work for a quarter just to reorganize a bunch of stuff. So that's the best approach that I've seen work. And then I think there were more questions. I need to scroll here. Okay.
Hey, Andre. Yeah, we're just coming to the end. So really appreciate you answering all of those. And as we said, hopefully, if you can get the answers to some of those questions, maybe across the email, we can forward them on to the guys, and we'll get that sorted. But really, look, big thanks to you for all of that so far. It's been great.
Yeah, it's fantastic, mate. It was a brilliant talk. I hope everyone enjoyed it and got some value out of it and had a good time too. I know a lot of people are in lockdown and stuff at the moment, so hopefully it was a fun hour and an educational hour too for everyone involved. We just wanted to do, I suppose, a quick wrap up. So a couple of winners. We had the Gopher card game winners. Congrats. Everyone that won today will be in touch. And you'll have the option of either some Amazon vouchers or some Golang merch. And given it's the Olympics, we thought we'd award the bronze medal to Abhishek in the cards game, because we kind of led him astray a bit, telling him he was the winner. And then, it all flipped on its head in the last question. So Abhishek will be over to you as well, mate.
Yeah, and all of the winners, obviously, we'll be contacting you, letting you know if you want some Amazon vouchers or some of the merchandise. Look, big thanks to you, Andre. It was a great talk, and we are going to be getting out the video to this edited to anyone that wants it in due course. We are working on that and the previous one, and we'd just like to announce, obviously, the next event that we have in a couple of weeks' time. I think Joe has some details on it here.
Yeah, so another, similar to the first talk, thread safety and Go is the first one. We got production ready concurrency next. So that's kicking off in a couple of weeks' time. Egon Elba has done some cool stuff in the Go community before, so we'll share some details on that. Same format, same time starting, and it'd be great to see as many of you guys here as possible. Been a really enjoyable hour. Hope you guys felt the same way, and we'll catch you next time.
See you soon, guys. And thanks again, Andre, mate. You've been really, really good talk today. Fantastic, actually. Great engagement, record numbers, and really good to see so many questions coming in from the community. So fantastic stuff over there at Encore. Yeah,
I think our quiz winner as well was Neil. Is that right? I think Neil. Shout out to you, Neil. And Andre, appreciate it very much, mate. It was awesome.
Well, thank you very much, everybody.
All right. Have a great afternoon, guys. See you in the next one. Right, is this recording now?
There you go.